For number 3, A, it says 5 squared times 5 cubed. Okay, so when multiplying like bases, you leave the base alone and you add the exponents. So it's just going to be 5 to the 5th power. Now, at that point I would probably just leave it that way, but just in case, that would be the same as 5 cubed times 5 squared. 5 cubed is 125, 5 squared is 25, so fine. 25 to 12, 1, 6, 0, 250, so 5 to 11, so 3125. So your answer here is 3125. Okay, and let's see, 1 second, so 5 to the 5th. Alright, yep. So for C, okay, I didn't copy out all the problems out of the book. 5 cubed over 25 squared. Now there's a couple ways you could do this, but I'm going to do this as 5 cubed, and instead of 25 I'm going to write 5 squared, which is the 25, which is still being squared. Okay. Now when you raise a power to a power, you multiply them, so this would be 5 to the 4th. Okay. When you divide like bases, you don't add them, but you subtract them, and you take the top minus the bottom. So 5 to the power of 3 minus 4, which is 5 to the negative 1. And like in an earlier exercise, to get rid of that negative exponent, I can write it as 1 over 5 to the positive 1, or just 1/5. Okay, so 5 cubed over 25 squared is 1/5. Okay, let's see, for A, 2 squared to the 3rd power, which means, okay, power raised to the power, so 2 to the 6th power. I tell you what, there's nothing wrong with doing that, but I'm actually going to jump over that, because in my head it's easier to say 2 squared is 4, and then raise that to the 3rd power, and that's 64. Okay, and I did it that way just because I had it memorized. You could have manually done it 2 to the 6th and gotten 64 either way. For C, 27 to the negative 1st times 27 to the 2/3, all to the power of 3. Alright, well 27 to the negative 1, I can write that as 1 over 27. 27 to the 2/3, let's see, the denominator I can use as the index, and the numerator as the exponent. Okay, so let's see, 1 over 27, so the cube root of 27 is 3, and 3 squared is 9. And this whole thing is still being raised to the 3rd power. Okay, now inside the hard brackets, I'm going to write this as 1 over 27 times. Instead of 9, I'm going to say 9 over 1, because that's how I think of it in my head, which means 9 over 27. Okay, 9 over 27 reduces to 1/3. Okay, now when you have an entire quantity like that, something divided by something, you can distribute the exponent. So this would be 1 cubed over 3 cubed. 1 cubed is just 1, and 3 cubed is 27. So your answer is 1 over 27. Or, yeah, 1 over 27. Let's see, for 5A, e squared times e to the 4th. E is a number like pi. If you put it in your calculator, and it'll come out 2.718 something something something. But in any event, when multiplying like bases, keep the base and add the exponents. So 5A is done. 5C, taking a power and raising it to a power, so this would be e to the negative 6th. To get rid of the negative exponent, 1 over e to the 6th. So number 5, A and C is done. And now for the last one in the set, number 6, 1 over e to the negative 2. Okay. Now, with the negative out front, what you can also do with a negative exponent is you can flip, if it's a fraction, you can flip the entire fraction and use it as a positive exponent. Okay, and then e over 1 is just e, so your answer is e squared. And lastly, for C, e to the 0, well, anything to the 0 power is 1. except there is one exception. 0 to the 0 power is not 1, but that's just a side note. But any other number, so x to the 0 is 1 for any value x, unless x is 0.